I could have your attention up here. Hey, today we're going to talk about similarity and transformations. Because of the bit of windstorm that we had there, we had to change up the calendar a bit. So today's similarity and transformations. So similarity and transformation, page 119 of your student journal. You guys can, hey, done talking? You guys could go through and fill out notes as we go through some of these problems. But really, we're going to apply a lot of the things that we learned in terms of transformations this chapter. So I want you to look at page 120 of your student journal. I want you to attempt number 1 with your groupies there. Okay. Oh, and also remember, in this book, they forget to tell you where to dilate from. So if they don't tell you, always dilate from the origin. So on these, your dilation should be from the origin. Okay, given our original, or our pre-image here, we translate it, we move everything back 5 on the x and down 3 on the y. That's what this is saying. Okay, so that is b prime. Okay, and then from there, we dilate everything from the origin. So from this point right here, I'm going to dilate everything by a multiple of 3. So this goes 3 times our x-coordinate. So this is what this is saying. It's, if we have the x-coordinate -1, 0 for c prime, you're multiplying -1 by 3 to get -3 and 0 by 3 to get 0. So c prime moves out here and becomes c prime prime. Okay. The other way to think about it is this length, this distance, has to become 3 times that. So that's 1, 2, and 3 out. D prime, which was at 2, 0, or 0, 2, now we multiply each of those by 3, it would be 0, 6. A prime, which is at -2, 3, now becomes, multiply that by 3, so -6, and that by 3, 9. And then b prime, which is at -3, 2, multiply it by 3 is -9, +6. Then our image, or our final image there. I messed that one up. Final image, if you shade it, would be that there. Okay. How many got it? Okay. Any questions on how to do that? Yeah, Alex?
So we only need to shade in the last figure?
Yeah, you only have to shade in the last figure. In fact, you only have to draw the last figure there. Connect points. Okay, once you go ahead and give numbers 2 and 3 a go. Okay. I think number 3 might actually go off, or at least one of your pieces might go off the graph, the grid. Number 2 goes off the grid? You sure?
I'm positive.
I think 2 might stay on there. Double.
Oh.
Nope, I think 2 stays on there. I think 3, 3 when you do the first rotation, it actually goes off. We've got RST. We're going to go ahead and take a quarter of each of those. So if I go a quarter of 12, that's 3. A quarter of 8 is 2. So 3, 2 would be my new R. X there. Okay, 1/4 of 8 is 2, so 2, 0. And then 1/4 of 4 is 1. T prime. And when we reflect over the y-axis, it just flips it over this line right here. Okay, so this point's going to stay right there. So T prime prime is going to be at the same spot. It's 1, 2, 3 away for that. 1, 2, 3. So R prime prime right there, and S prime prime is 2 away. All right, how many got that one? Okay. Questions? Okay. Who's done with number 3? Okay. I'll give you guys another minute or so on it. In fact, I'll just start plotting the points while you guys are finishing up there. Okay, that would be our rotation. Kind of goes off the grid there. We rotate it 90 degrees. I went counterclockwise. And then 2/3 of that, I'm just going to go ahead and put it up there. That is our final shape. Okay, so 2/3 from the origin. Y is 2/3 away. Okay, X 2/3 away, and Z. So if we were to go through those points, 2/3, 2/3. Okay. Questions? Okay, so last piece. I want you to take a look at the next page. Number 4, describe the similarity transformation that maps the pre-image to the image. Now, when you're doing this one, it can be multiple things. Now, remember last week when we talked about this, we talked about always looking at your orientation. Tell your neighbor what orientation means.
Where you go like this. Like this.
Okay, so has the orientation changed on number 4?
No.
Remember orientation when you're reading them, L, so L, M, N, it's going clockwise, and L prime, N prime, N prime. Therefore, if the orientation hasn't changed, which of our transformation has not been performed? Danica? Good, it has not been reflected. All right, so looks like this one, there's different ways we can go about it, but go ahead and figure out how you can map LMN to L prime, M prime, M prime, N prime. Okay? Any thoughts? What's one thing that's happening to it, for sure? Yeah. Yeah, it's been a reduction, right? Okay. Could have been reduced from, oh, is it going the same distance from, say, N to N prime as M to M prime? Are they proportional? Yeah? So if I go from here to here, okay, or excuse me, if I am jumping out from here to there, and here, are all these distances proportional? How are we figuring out our reduction here? Right? Okay, so you say this length is 3. All right? And so did you do that on this one? Okay, what's this? 6. So this is 1. This is 2. Okay, so it looks like our scale factor then would be 1/2. Okay, so our scale factor is 1/2. All right, where are we dilating from? Yeah. Okay. Anyone else? All right. Put some more time into it.
I did it right, but I translated it x plus 1 and then y minus 4. Then I dilated it 1/2.
Okay, so you moved it a vector of 4. Oh, x plus 1?
Yeah.
I'm sorry. So 1 and then y minus
4.
minus 4. Okay, so you moved it a vector of 1, 4. Okay, 1, negative 4. So you said this point moves 1 unit to the right and 4 units down. Okay?
Oh,
And then this point moved 1 unit to the right and 4 units down. Okay? So if we, and this point moved 1 unit to the right and 4 units down.
yeah.
All right? And then what did you do?
Having the center at L prime, dilated it 1/2.
You went 1/2 from L prime?
Yeah.
Okay. You said this distance, rather than being from here to here, went from there to there. Okay, so you dilated from this point there.
Yeah.
Okay, Jeremiah?
I had to reduction of half first and then right 4 and down 4
Okay, you reduced it by 1/2 first. From what point? From point L? And then you went right, and then you slid it? Okay. You could have done the same thing, yeah. So you could reduce first. You could say, okay, from here I'm going to reduce it, and then I'm going to slide it to match up here. Okay, you just have to make sure you say where the center of your dilation is. So there are multiple ways to do it, but you've got to say, hey, I'm going to dilate from whatever point, and then I'm going to slide it. So if you did that and you cut it in half, so each of these points cut in half from there, and then slit it, that would work out. Okay? All right. Very good. Try number 5. Last one. Guys, first thing you need to ask yourself is, does the orientation change? Does it change? ABC going counterclockwise, ABC going clockwise. So orientation changes, which means at some point you need to reflect it. Okay, and it looks like this one reflects that way somehow. Okay, notice if I was to use the y-axis as a line of reflection, this point C prime is 1 unit away, or excuse me, C is 1 unit away from the y-axis. So if I reflect it, it would move it right here. And then B would move 3 units away, which would be right there. And A would move 3 units away, so that would be right there. If I reflect it over the line, over the y-axis, I could then try to do what to it? Yeah. Dilate by 2, okay, from the origin. Talk to your neighbor real quick. Where are you going to dilate from, and what would your scale factor be? All right. Time's up. Let's say, hey, you guys, if I currently my point A is, or my reflection of A is at 3, 3, and I want it to get to 6, 6. So one way to look at this is go, well, I could think of it as that, and I need to get to 6, 6. If I dilate from the origin, if I multiply each of those by 2, I'm good to go, right? If we try it here, we could say, well, that's 3, 1, and I need to get B to become 6, 2. Does multiplying by 3 make it work? Or excuse me, multiplying it by 2. Does multiplying by 2 to make it work? Yep. And the same thing would work here. This was 1, 1 and 2, 2. Okay, if we double each of those. So it looks like a reflection in the y-axis. And then dilate by 2. Okay? Make sure you go from origin. All right. Alex.